This cancel this. Okay, divided by 2. And if you have 2 in 10, we have 5. That is, we have 1, 2, 3, 4. Then meter. And this can be written as 1, 2, 3, 4, which is 5 times 10 raised to the power 4 meter. That's the height. And that is the simple solution to that question. Question number 2. Two divers, G and H, are at the depths 20 meter and 40 meter respectively, below the water surface in a lake. The pressure on G is P1, while the pressure on H is P2. If the atmospheric pressure is equivalent to 10 meters of water, then the value of P1 divided by P2 is, we have to calculate what will be the value of P2 over P1. That's what the question says. If you look at that question, we are given the normal pressure at the depth of the lake for those two divers, the pressure that is working on them. So now we are given the atmospheric pressure, which is the pressure above the sea level. So what will now be the value of P2 over P1? What we are going to do in this case is as simple as this. We are going to have the P1 will be equal to the atmospheric pressure plus the height. If you look at that question, we are given the depth, which is our height, for the G, okay, which is 20 meters. We are going to have the atmospheric pressure in the question is 10 meters. We are going to have 10 plus our height, which is 20. So altogether, we have 30 meters of water. That's for P1. For P2, we are still going to have atmospheric pressure plus the height. Okay? And our atmospheric pressure still remains the same, which is 10 plus. Then for P2, and that one is dividing to the diver's H, which is 40 meters. Then we are going to have altogether 50 meters of water. If P1 is this, P2 is this, then the whole thing is simple. Then P2 over P1 will be equal to 50 divided by 30. And what we are going to have there, it will be 50 divided by 30, 1.6666, approximately 1.67, because this is pressure, this is pressure. It will not have any units. Because pressure, you have the unit, you have the unit, which cancel each other. Then the answer is 1.67. And that will be the ratio of the two pressure. Question number 3. The question says, what is the length of the liquid column in a barometer tube that will support an atmospheric pressure of 10,102,000 Newton per meter squared if the density of the liquid is 2600 kilogram per meter cube? And we have to take the value of G to be equal to 10 meter per second. The solution to the question will go like this. We are given the pressure to be equal to 102,000 Newton per meter square, and we are also given the density of the liquid to be equal to 2,600 kilogram per meter cube. We are given the value of G to be 10 meter per second squared. Then we have to calculate the length of the liquid column or the height. We are still coming from the pressure is equal to density our G, our height. The pressure, which is 102,000, will be equal to density, which is 2,600 times 10 times h. Our h will now be equal to 102,000 all divided by 2,600 times 10. Okay? And if you are having that, you can 102,000 all divided by, let's quickly multiply 2,600 by 10. We have 26,000. Okay, 0 times 0. What we are having left is 102 divided by 26. And once we are having that, we can quickly calculate what will be the value of 102 divided by 26, and that will give us 3.9230. Okay, and approximately we can have 3.92 meter. Question number 4. The question says an effort of 400 exerted on an hydraulic press is just sufficient to move a load of 3,600 Newton. If the diameter of the small piston is 10 centimeters, find the diameter of large piston. In this case, the word effort is used instead of the word force. It's the same thing. You can say a force of 400 exerted on an hydraulic press, or effort is the same thing. Okay? By the time they apply the force or the effort at the other side, where we have the smaller cylinder, okay, they apply the piston, and the force applied is 400 Newton. Then that one move a load of 3,600 at the other side of the cylinder, with the one with the larger piston. So we are given the diameter of the smaller piston to be 10 centimeters. What will now be the diameter of the larger piston or the large piston? We are coming from here. I'm using weights this time around because we are told that the effort of 400, by the time it is being exerted on the hydraulic press, it moves a load of 3,600 at the other side of the larger piston. Okay? And when we are talking about the load, automatically is a weight divided by that of the efforts applied. And the effort applied here can be taken as the applied force, which is equal to the diameter of large piston divided by the diameter of smaller or small piston. Okay? This can be written as weights over the applied force D2 D1. Let's take it like that. Okay? For our weights, we are having in the question that is 3,600. For our force that is being applied is 400. We are looking for D2, which is the diameter of the large piston. Then we have the diameter of the smaller piston has been given, which is divided by what? 10. Okay? So let's make D2 the formula. We are going to have 3,600 times 10 divided by 400. And what are we having there? Please cancel this. Okay? Let's divide 360 by 4. And if we try to do that, we are going to have, when we have 360 divided by 4, that's 90. That's our D2. We have to calculate what will be the diameter of the larger piston, okay, and that is 90 meter. 90 meter. Question number 5. The question says, in a hydraulic press, the surface areas of the piston are 8.0 times 10 to the power minus 4 meters squared and 4.0 times 10 to the power minus 2 meters squared respectively. If the smaller piston is pushed down with a force of 120 Newton, with what force is the larger piston pushed up? This is a very simple question. We are given the surface area of the piston. For larger piston, A2, as I've given to you in the formula, is 8.0 times 10. For smaller piston, which is A1, which is equal to 4.0 times 10 raised to power minus 2. Then we are given our small f, okay, and that is the force, that is the downward force we use, okay, to exert a force, a pressure on the area or the small cylinder, the smaller part of the cylinder, okay, which is 120 Newton. 120 Newton. We are told what will be the force of the larger piston, and that is curve. You can come around and say force on